Hello guys, nice to meet you. I'm Jean-baptiste Aviat. I'm CTO at Sqreen. Previously, I worked at Apple in a security team, and so now I'm at Sqreen. Most of the things I'm gonna describe here were done at Sqreen with Benoit, who's our first employee. And so we have no ops. So basically, we are the ops still today. So what is Sqreen and how does it work? Basically, Sqreen is like New Relic, but for security, right? We operate and monitor the security of your application. The involvement is that we do few raids because when your application starts, it gather the rules pack, which includes a lot of security algorithm and security data to protect your application. Then your app is running, right? You don't need to discuss with Sqreen anymore, but for monitoring, right? And so we get a lot of writes because your application is sending all the time information to us, like the errors we encountered, the attacks we blocked, and all security-related things that help us to protect your app. So that's just a global overview of how Sqreen is working, and you need to know that to understand the challenges we face for scaling. So just a legal disclaimer, I need you to read all of it and just raise your hand when you're done with it. No? Okay, no. The disclaimer, it's not about that. The disclaimer is, yeah, in this presentation, we discuss about production outages because we had a couple. Just I want to tell you that our customers are not impacted by these production outages because like we don't redirect traffic, all the protection is done inside the application. So even if Sqreen is down, your application is still protected, right? This does not involve things. The only issue is that our new customers cannot subscribe, right? And so it's still quite bad. And obviously we have a delay in the monitoring. Anyway, when we started the company, obviously we had no client, so 0 RPM. RPM, everyone know what it is? Request per minute, right? So 0 RPM is no traffic. So we started with bare metal. Yes, obviously. You know that it's not high quality bare metal, but you know we were 2 developers. That was enough for no client. Docker, Git running on it. It was good enough, right? Quickly enough, we get our first customers, right? So like 10 RPM, say, and we figured out we needed to move things into real production. So we went to AWS. We are a startup. We were in a co-working place. AWS was free, so it was really easy to get started with that. I'm like a network geek, so it was just a pleasure to see what you can do in AWS, VPC network. You can build your subnets, put your router wherever you want. It was a pleasure. We were on Docker, so AWS has ECS, so we started with that. And with a small cluster of 2 T2.small machines. So why do you need 2 instances? So it was like 2 years ago, right? And ECS, it was just the beginning. So ECS, basically, you can think of it as Kubernetes, but by AWS. And in the days, it was not really powerful because the issue was that when you start a service, you need to listen on a given port, and the TCP port was static. You could not, you were not allowed to let Docker choose the right port. So we had to have 1 service on 1 machine. You could not have 2 services on the same machine if they were requiring the same port. So it was terrible, no scaling, or you need to boot more machines to put more services in it. It's not really the Docker way, but it was the beginning of ECS. You had no choice at that time. And so if you don't want to have a service interruption when you deploy, you need to have a second machine because you need to put the new service somewhere, shut down the old one, and that's it. If you have only 1 machine, you cannot have a continuous deployment. So then it was T2 machines. Do you know what a T2 instance is for AWS? It's the worst. So it's good if you don't know. Basically, they are burstable instances, right? If you don't use it, everything's fine. But as soon as you start using the CPU, well, you have a credit in CPU, and the credit is decreasing. This is the blue curve on the left graph, right? So the peak is decreasing. If the peak reaches 0, basically you are not allowed to use the CPU on the machine anymore. So it's not the best for a server, right? It's cheap, but if you run a production like that, you don't have very good nights. It was 10 RPM, it was okay, but quickly enough, we went to 100 RPM, right? More clients, okay. And yeah, with the first clients, they first get attacked, so we have a lot of metrics to process. And yes, that's led to our first scaling issue, right? So what do you do in this case? You're a developer, obviously. You optimize your code because it's slow, so you optimize your code. No, and that's where we change our mind a bit. We are a startup, we need to go fast, we need to iterate quickly on features. So no, okay, we have this feature, it's working, just it's slow. Okay, so let's boot another machine, right? And do not spend time on something that is already working. We might want to optimize it later, but today we don't pay, and we need to push more features to get more customers. So all right, let's just do that. So we booted more machines, but with more than one machine running, well, the complexity of your service is scaling, right? Because how do you read the logs? On one machine, it's easy. On several machines, it's more complicated. How do you monitor the machines? One, easy, many, complicated. And how do you catch and read the exceptions? So all of this was like our first step into the cloud, right? Into the SaaS. We use Logly for log management, New Relic for performance and monitoring, and Sentry to monitor the exceptions. Useful services that are like the ground of our infrastructure. Then, luckily enough, AWS released the ALB. So it's like the HTTP gateway of AWS, but next generation. So this new load balancer removed the limitations we had on port binding with Docker, right? So with this load balancer, we have been able to spawn multiple Docker services on the same machine, right? So we have been able to reduce the size of our Docker services, to choose really and very precise limits in terms of CPU and memory on the services. And so we've been able to put a lot of these services on the machines we had in the cluster. And so as well, we have been able to do per service auto scaling, right? Since we don't need to boot a new machine each time. Well, that's the first auto scaling that you have, and that is really good. And so we realized that our cluster was clearly CPU bound. So the auto scaling were performed on the CPU, right? If CPU usage is too high for a service, well, we boot more services at this time. And in our whole Docker cluster, if the CPU reservation is too high, meaning there are demand for services that the CPU of the cluster cannot satisfy, well, we launch a new machine, right? So all of this is automated, and it was working really well. Then we went to 1K RPM, more customers. Okay. Did I mention that our database was MongoDB? I think I did not, right? So it's a database that has not a really good reputation, but it works. It really works. I'm not the one administrating it, so it's okay, but it works. Anyway, when you have that in your production, if the database fails, the data ingestion is really slowed down, and it was slowing everything down. So it was not really good to have that in the middle of your HTTP API processing, right? So soon enough, we moved to SQS, which is a queue service. And so the HTTP endpoint, we are doing no more MongoDB, only pushing in SQS, and we have some digester later that do the trick. You can see here, when we deploy the queue, we had a really a nice improvement on the graph, and we clearly see that we don't rely on MongoDB anymore. That's a queue. That's wonderful, but how do you monitor it? It's not easy. You cannot read what's inside your queue, right? So you need some specific tooling. In our case, we are using New Relic Insights. New Relic Insights allows to receive a lot of metrics, and it helps and allows you to build any graph you want on top of that. So we are able to see how many kind of things we digest, and you can see we are like processing a lot of attacks and less metrics, and you can as well see the digestion time taken per customer. So you can easily analyze if one given customer is giving you a hard time or is using your CPU cluster a lot. So the deploy of SQS was really a good thing. We were very happy about it. And we felt quite happy about ourselves because we handled bigger customer and it was really smooth. So really good thing. Yeah, so sometimes you had prod issue, and I think it was our first big production issue. It was like maybe a 10 minutes outage, a bit more. I don't remember exactly, but it was extremely stressful, and we have customers that are very closely monitoring their new relic. And so even if we don't have impact on their application performance, if they see something like external service raising up and triggering error, it's not good at all. And so we are very keen to deal with this kind of things. So it was our login endpoint that were taking too much time. Why is that? Because when someone deploys his production and his production is protected by Sqreen, obviously all the servers need to do the login at Sqreen, right? To get a session ID, etc. And this login endpoint was too slow. So it was the issue. Our RPM during the outage went to 0 because our server were not able to process anything more. So the emergency fix, yes, we boot way more machines, and it allows us to take the traffic for a while, and everything was back during giving us some time to fix the issue, right? So we put this login payload into memcache, and it makes everything faster. No more Mongo read on logins, etc. So the login endpoint was way faster, and we've been able in the end to manage handling this customer and reducing back the size of the cluster. Whew, good thing, stressful, but it was okay. So the Friday evening, we all went to a bar and take a beer and be happy about ourselves. Though was not over. It was not over. Despite all the clients, the new clients we were having, we still had some performance issues. And the more customer, the more stress. So yeah. So no, it was really Friday evening, like past 7 or 8 p.m. And so we were in a bar, so we had to get home. Luckily enough, our office was very close to the bar, but after a couple of beers, the path is a bit longer. Hopefully Benoit does not drink and was the one looking at the monitoring while we were doing it. So it was Friday evening. It was a big customer deploy, right? Friday evening in the valley, it's like Friday in the morning, so it's okay. But no, it was people from Ireland. So it was Friday evening as well for them. So these guys were like a huge company, and they were pushing their whole production with a new service, and we were, yeah, okay. So we should have worked. There is no question, but it was surprising for us to see a really big guy pushing something like that in production on a Friday evening. Sqreen was extremely young at that time. The issue was our login endpoint was still too slow. Emergency fix. Yeah, we boot more machines, right? It works and it saves the day. But now, how do we fix it? So this time we have set up PagerDuty, right? We were lucky enough to have Benoit in the bar looking at the monitoring. But we want to know about that if it happens in the middle of the night, right? So PagerDuty is now waking up us from time to time. And we changed the way the agents are discussing with the server at login time, right? So we had like 4 requests, and we moved all of it into one request that we carefully optimized, and it made something way better. Then we went to 10K RPM, right? So it's a bit more. So we had like auto scaling, take 2. We needed to scale faster when HTTP requests are peaking, incoming, and each time like a big customer is rolling out its production. So we read this information from the AWS load balancers, the number of incoming requests. We put it into Lambda, and we have like an algorithm in Lambda, a formula that is computed and that updates the number of desired services. So we are able to scale our cluster using that, all right? So we scale the number of services depending on the number of incoming connections, and later we add more machines if the cluster reservation is not enough. But it's still too slow, even with all of this. So because when you boot a new machine, you need like 2 to 5 minutes on AWS to have the machine from booted to operating, right? So we keep a reserve. That's a service that mimics a small portion of our infrastructure and that allow us to handle any new large customer that would be coming in. When I say large customer, it's like thousands of machines, right? It's not the average production, but this kind of guys at the beginning were quite a surprise. Today we are up to 40K RPM. It's growing, so it's still a challenge to face the growth of this API. But today we cannot fail anymore. We have bigger customer. We have complete security teams that are looking at Sqreen and how Sqreen is operating. So we have no choice. We need to be reliable and resilient all the time. So as I told you, we have provisioned some capacity for handling new customers. And we also do a lot of load testing. So load testing for us, I don't know if you know bees with machine guns. We use something very similar. Basically, it's just a simple Kubernetes that we boot when we need it with maybe 60 to 100 to 500 machines to simulate a big client production. And we just hit our production with these kind of things. And this allows us to adapt the production as it should be and to adjust our code or our infrastructure if we need it to be more responsive. The next challenges we want to have like a smoother handling of big customers. We don't want it to be that stressful for us. We want to reduce our cost because AWS is costly, and so we could be better on this. We want to improve our storage system that is still 100% MongoDB, reducing the latency because we would like to have like word present, so our customers will monitor that Sqreen is really fast in their new relic, even though it does not impact their production, but that's still a metric that our customers are looking at. And we want to remove the impact of a client failure or perf impact on anything at Sqreen. So today we have 40K RPM, and so some numbers about Sqreen. Any questions, guys? Yes. Ah, je promets rien.
Yeah, so you had a lot of problems with your database handling, and I was thinking, is it due to the choice of using MongoDB, or is it due to like failing in actually engineering it properly in the first place? Because when you said you had 4 requests to the database for 1 login, it sounds like it's not really Mongo's fault.
Yes, you're right. You're right. We know how to design the perfect system today, right? The thing, and it's always a trade-off when you start a company. You know you have something in mind that could scale perfectly and that could be perfect, right? But you don't have the time and resources to build it. It's always a trade-off. You need to prioritize getting new customers at some point, because if you have the perfect production with 0 customers, it's useless, right? So yes, we know some design choices were poorly made at the beginning because we were in a rush, right? And obviously later we have been improving on this kind of things, right? And for instance, the number of machines we used at the beginning of the summer was like 30. During all the summer, it was the summer, but we still get a lot of new customers. We like multiply the size of our infrastructure, of our incoming requests by 5, and we reduce the number of machines from 30 to 10, right? So with more clients, we managed to, so yes, we can do it. Obviously, we had some choices that were poorly made at the beginning, but because we needed to iterate fast, and yes, we are working on it. Thank you, guys.